Today's problem was submitted by a viewer, and it says, given complex numbers z1, z2, z3, with z1 not equal to z2, but the modulus of z1 equals the modulus of z2 equals the modulus of z3 is equal to r greater than 0. Prove that the minimum of this expression is equal to 1 over 2r times some other expression. Okay, let me write out exactly what we've got here. I mean, they're complex numbers, but the fact that they're complex numbers doesn't really have anything to do with this, unless there's some sort of fancy result of complex analysis which would apply here, but it seems like it's more of a geometric problem, right? We have 3 points on a circle, and this is some sort of not a weighted average of the points. What is it? I mean, maybe this is going to trace out a straight line in the plane. As k ranges over the reals, this will give us a line. And then we're asking for the point on the line closest to the origin. Would it be an absolute disaster to just write out arbitrary coordinates of z1, z2, z3, figure out the equation of the line, and show that the closest point is given by, or the distance of the closest point is given by that? Right, we could maybe even explicitly do the minimization with respect to k here. You know, whatever, I'm just going to go for it. I mean, maybe there's an elegant result that can be used in here, but I don't know what it is. Looking at this, I don't see exactly what that elegant result that we can use is here. I mean, this technically should work if this is true, but okay, so we have arbitrary points that are all on a circle. All of these are equal to r squared. Okay, so I have kz1 plus 1 minus kz2 plus z3. This is a point which is equal to kx1 plus 1 minus kx2 plus x3. ky1 plus 1 minus ky2 plus y3. Okay, so rather than minimizing the modulus, I'm going to minimize the modulus squared. Same thing. Let's call this point z. Okay, so I want to minimize this as a function of k. I'll take a derivative with respect to k. And this should be equal to 0. Well, let's group some terms up here. So in terms of the algebra, this is the part where we need the points z1 and z2 to not be equal. Otherwise, this denominator would be 0. We wouldn't really have a well-defined line. This set would not be a line if z1 were equal to z2. It would only be a single point. It wouldn't actually depend on k. Okay, so that's the value of k, which attains the minimum distance from the origin. Looks like it's going to be a bit of a disaster to substitute all this stuff in. Okay, where's my distance function? It might have helped to expand this. Okay, so I've worked out a whole bunch of algebra and details here. I'm not using this method anymore. I'm just going to complete the square. I've written the modulus squared like this and simplified to write it as a quadratic expression in k. So I've got a k squared there. I've got a linear in k there. Completing the square, I mean, I know that this coefficient is positive. I've seen that coefficient already. So the minimum value of this for all values of k is just going to be whatever that is. So I just have to identify what these constants a, b, and c are. There we go. Now I want to compute this and see if it's equal to the thing that we're given in the question originally. I don't know if this will be, this might be pretty messy, but we'll see. Oh no, I have a sign mistake somewhere. All the way back to the beginning, that was a minus sign. So of course, I really should replace Z3 with negative Z3 everywhere. So those should become plus signs. But even so, I don't see exactly how the expression that I've written here can be manipulated to get what was originally given. Now, I haven't actually used yet anywhere that the modulus of all three numbers is the same, because I mean, I don't actually see the modulus coming out exactly. Maybe I'll just compute one more thing quickly. I don't know. I mean, I don't know if this is the best way to do it. It's certainly extremely tedious. Maybe if I had actually figured out what line this is tracing out here. I mean, when k is equal to 1, oh my god, but I forgot the negative sign here. When k is equal to 1, I've got z1 plus z3, which is about there. When k is equal to 0, it should be z2 plus z3, which is about there. So we have some kind of straight line looking like this. I don't know if there's a little geometry result that works here. I don't know. This has turned out to be very tedious, at least the way that I'm doing it. And I don't want to have to go back and figure out whether my typo with the negative sign actually affects too much of the work that I did. So I'm going to stop here. Yeah, this is one way of doing it. It's clearly very tedious, just a lot of algebra, and at the end I still wasn't able to make this expression look exactly like the thing we're given anyway. So I'm going to stop here. Thanks for watching. A little while ago I went through a problem that was submitted by a viewer. It's the one that I have written down here, and spent a lot of time going through some computations and didn't realize till the end that I had a typo in the question. I had written this down with a plus sign instead of a minus sign. I did catch this mistake, but didn't want to spend a huge amount of time going through the solution again, especially considering the method that I used was very tedious. I don't think it was really the way that was intended to solve this problem. But then after editing that video and looking at this expression more carefully, written correctly with a minus sign here instead of plus, there's another geometrical interpretation of what's going on here. So I'm at least going to get started with a new solution to this problem. Hopefully what I do here will lead to something meaningful. Unfortunately, the interpretation here is extremely geometrical, and if you know me or have watched much of what's on my channel, not only am I not very good at geometry type problems, but I don't even particularly find them enjoyable. So I'm at least going to lay this out, maybe take a few steps towards the solution, and then if I get stuck somewhere, I'm not going to fuss too much and spend a huge amount of time trying to figure things out. Anyway, for some reason, when I rewrite this expression correctly, it's a little more clear what's going on. So if I look at the first two terms here, as k ranges over the real numbers, this is going to trace out a straight line in the complex plane, and it's going to be the straight line which goes through the points z1 and z2. And then, of course, this entire distance is this magnitude, this modulus, is the distance between z3 and that line for values of k, and the minimum is going to happen when you draw a perpendicular from z3 to that line. So let's sketch out exactly what's going on here. So this is supposed to be a circle of radius r. I'm just going to put on some arbitrary points like this. We'll call this z1, z2, and z3. And as k ranges over the real numbers, different values of k are just going to give us different points that are on this straight line connecting them, like so. And this whole minimum is essentially nothing more than the distance between Z3 and this line. So we're going to drop a perpendicular to this line from Z3, and we want to compute the magnitude of this distance. Now this, the way I've drawn it here, this line segment connecting Z3 to the line is fully within the circle, but that doesn't necessarily always have to be the case. For example, if Z3 were over here, it would connect outside of the circle. So now that I've drawn this, we can identify some of the quantities on the right-hand side also. This distance is this first magnitude from Z1 to Z3. We also have one from Z2 to Z3. And we're dividing this by 2r. Now all of 3 of these points lie on the circle of radius r. So how might we go about computing? So I want to compute the height of this rectangle, or a triangle. I want to compute the height of this triangle. I mean, I feel like at this point with this sketch, there's going to be a whole bunch of identities that have to do with the geometry of a circle. Yeah, I don't know. I mean, this is an Olympiad level problem dealing with one of my least favorite areas of math, unless there is something about complex analysis that's going on here that I'm not seeing the connection to some theorem. I don't know. I have one idea. I'm going to draw something a little bit bigger. Again, it's going to be really difficult to work in the radius part of this, but I'm going to call this point Z4, and H will be the height or the length of that perpendicular. So the area of the triangle is the distance from Z2 to Z1 times H over 2. We also know that it's if I write it as the sum of the areas of the smaller triangles, and H is what we're looking for. Is there something we can say about these quantities? I really just don't want to go through the tedium of all this. Honestly, if I were like forced to solve this problem, I would go back to my old method with the analytical version of things. I'm tempted to just like spend some time sitting here right now doing that with the correct version of the problem. I don't really want to leave this one completely unsolved.